Good morning, my dear students. Today, in this video, we are going to learn about motion of an object and types of motion. A body is said to be in motion when its position is changing continuously with time relative to an observer. That means there should be a change in the position of the object. That means the object must have speed or velocity. Then, what is velocity of an object? The displacement of an object in specified direction is known as velocity. That means velocity has a specific direction and magnitude. According to velocity, motion can be classified into two types. They are uniform motion and non-uniform motion. Let us first understand the uniform motion. Consider a cyclist moving on a straight road. Let us assume the distance covered by him with respect to time as follows. For 1 second, he covered 4 meters. For 2 seconds, 8 meters. For 3 seconds, 12 meters. And for 4 seconds, 16 meters, etc. With this data, let us draw a graph between distance and time. We will get a straight line passing through origin. This straight line graph shows that the cyclist covers equal distances in equal intervals of time. And also we can understand that the instantaneous speed is equal to average speed. If the direction of motion of the cyclist is assumed as constant, then we conclude that velocity is constant. This type of motion is called uniform motion. That means the motion of the object is said to be uniform when its velocity is constant. Now we are going to discuss about non-uniform motion. Motion of an object is said to be non-uniform when its velocity is changing. The change in velocity takes place in three ways. First one, speed changes with direction remaining constant. Second one, direction of motion changes with speed remaining constant. Third one, both direction and speed change simultaneously. Let us understand the first type of non-uniform motion, that is, speed changes with direction remaining constant. The best example for this type of motion is the motion of a ball on an inclined plane. Let us do an activity. Let us set up an inclined plane as shown here. Let us take a marble as a ball that moving on the inclined plane. Take this ball and release it from the top of the inclined plane. What is the path of this ball? Yes, this is the path of straight line. That means the direction of this ball is constant. Now, let us look at the ball to observe its speed once for every second. Now, at 0 second, the ball starts at 0 inches. After completion of 1 second, it reaches 11 inches. That means, for the first second, it travels 11 inches distance. After completion of 2 seconds, it reaches 25.5 inches. So, for the second, it travels 25.5 minus 11, that is 14.5 inches distance. After completion of 3 seconds, it reaches 45 inches. So, for the third second, it travels 45 minus 25.5, that is 19.5 inches distance. After completion of 3.7 seconds, it reaches 60 inches. At that rate, by completion of 4 seconds, it may reaches 66.5 inches. So, for the fourth second, it travels 66.5 minus 45, that is 21.5 inches distance. On close observation, we find that when the ball moves down the inclined plane, its speed increases gradually and the direction of motion remains constant. That means the motion of a ball on an inclined plane is a non-uniform motion. Now let us observe the motion of a ball moves up from the bottom of the inclined plane. Take a ball and push it with a speed from the bottom of inclined plane so that it moves up. What is the path of this ball? Yes, Here also it is in straight line. That means direction of this ball is constant and its speed decreases gradually. So the motion of a ball moves up from bottom of an inclined plane is also a non-uniform motion. Now let us look at the second type of non-uniform motion. That is, direction of motion changes with speed remaining constant. Look at this fan. What is the motion of this rotating fan? Yes, it is uniform circular motion. Let us observe it in slow motion. Now, let us tie a small object to one of its wings and observe the motion of the object. Here, the object moves in uniform circular motion. That means the object have constant speed. Let us draw its path of the motion and velocity vectors at different positions as shown here. What is the path of this object? It is clear that the path is a circle and the direction of velocity changes at every instant of time, but the speed is constant. Hence, in this activity, we observe that though speed remains constant, its velocity changes. So, it is a non-uniform motion. Now, let us look at the third type of non-uniform motion. That is, both direction and speed change simultaneously. Best example for this motion is the motion of an object thrown into air. Observe here, throwing a ball over the table so that the ball tends to make some angle with the table. Let us observe again in slow motion. Draw a diagram to show its path and velocity vectors. Is the speed of the ball uniform? No, it's not uniform. Is the direction of motion constant? No, it's not constant. So in this activity, we have noticed that the speed and direction of motion both change continuously. So the motion of an object thrown into air is a non-uniform motion. So far in this video, we have learned about uniform and non-uniform motion with suitable examples. From this video, we have concluded that due to the change in velocity, non-uniform motion occurs. Then, what is the rate of change in velocity? We will learn about this in the next video.